In this video, we're going to look at the general multiplication rule. The general multiplication rule says that if you have two events happening in a series, so first one happens and then the other happens, that you find the probability of them both happening by taking the probability that one happens times the probability that the other one already happened. So what we like to do for these is use tree diagrams, because it makes it a little bit easier to organize your thoughts. So here's a very simple example where we're going to flip two coins and we want to find the probability of getting a heads both times. So you start with your action, which is we're going to toss a coin, and then you branch off with your outcome. So your outcome is either a heads or a tail, and you also write in the probability. So there's a 50% chance that you get a heads and a 50% chance that you get a tail. Once you've got a head on the first flip, then your second flip could either be a heads or a tails. And you continue filling out the rest of the chart like that. And then you follow through all of the different possibilities. So this first possibility is that you get a heads on the first flip and a heads on the second flip. And you multiply the probabilities as you come across them. So you're doing 1/2 times 1/2, which equals 1/4. Whereas the next outcome would be, maybe we get a heads on the first flip and then a tails on the second flip. And that would be 1/2 times 1/2, which equals 1/4. And if we continued with that, we would get all of the different outcomes and all of the different probabilities. Now, one way for you to quickly check your work is to check to make sure that these final possibilities, that all of those probabilities add up to 1. That's a way to make sure that you haven't made any mistakes. Now let's look at an example that's a little bit more complicated. We're going to make a tree diagram of this situation. So we have a computer company that makes desktop, laptop, and tablet computers at factories in 2 different states, California and Texas. The California factory produces 40% of the company's computers, and the Texas factory makes the rest. Of the computers made in California, 25% are desktops, 30% are laptops, and the rest are tablets. Of those made in Texas, 10% are desktops, 20% are laptops, and the rest are tablets. All computers are first shipped to a distribution center in Missouri before being sent out to stores. Suppose we select a computer at random from the distribution center and observe if it was made, where it was made, and whether it was a laptop, desktop, or tablet. So to make the tree diagram, the first thing we're going to do is make the branches to represent the different things that could happen or the different outcomes. So first, we have all of our computers. And the first thing that happens is they're either made in California or Texas. There's a 40% chance that they're made in California, and that means the other 60% are made in Texas. The ones that are made in California have a distribution where 25% are desktops, 30% are laptops, and the rest, so 100% minus 25% minus 30%, so the rest is 45%. Those are tablets. We have something similar happening in Texas. With 10% being desktops, 20% being laptops, and the rest being tablets. So we've got 30% so far. That means there's 70% left over to be tablets. So just like we multiplied the different branches to get the probabilities of each of these outcomes, we're going to do the same thing here. So we're going to do 0.4 times 0.25, and that gives us 0.10. 0.4 times 0.3 is 0.12. 0.4 times 0.45 is 0.18, and we'll continue that. 0.6 times 0.1, 0.6 times 0.2, 0.6 times 0.7. Okay, if we do a quick check, these should all add up to 1, which they do. Next, we want to find which percentage percentage of the computers are tablets. So we have to find the percentage that were tablets made in California and the percentage of tablets that were made in Texas. So that gives us a total of 60% of all of the computers that are tablets. Next, let's say we want to find the probability that we select 4 computers at random from the distribution center with replacement, which means we're going to put the computer back before we draw the next one. And we want to find the probability that at least one of the 4 that we pick out will be a tablet. Now, the probability of at least one means that they could be 1 tablet and 3 non-tablets, or 2 tablets and 2 non-tablets, or 3 tablets and 1 non-tablet, or 4 tablets. So that or problem means that we could find those 4 possible scenarios and then add them. Now, what's easier, especially when these get to be much larger problems, is to remember that the probability of at least one is the complement of the probability of none. So it's usually easier to find the probability that none of them are tablets and then find that complement. So the probability that none of them are tablets means that the first one is not a tablet, and the second one is not a tablet, and the third one is not a tablet, and the fourth one is not a tablet. If there's a 60% chance that any individual computer is a tablet, that means there's a 40% chance that any individual computer is not a tablet. So the probability that the first one is not a tablet is 0.4. And the probability that the next one is not a tablet is 0.4, and so on. So that would mean we would multiply 0.4 times 0.4 times 0.4 times 0.4 4 times for the 4 computers that we're choosing. Now, rather than write that out as multiplication, it's going to be a lot easier to use exponents. So 0.4 to the 4th. That gives us 0.1296. So there's about a 13% chance that if I pick out 4 computers with replacement, that none of them will be tablets. So the complement of that, if I do 1 minus that value, I get 0.8704, which means there's about an 87% chance that at least one of them is a tablet. Now for this last question here, I want to know, given the probability that the computer that I picked was a tablet, what's the probability that it was made in California? So given that it's a tablet, what's the probability that it's made in California? This is a new formula, and we want to take the probability of that it was made in California, and it is a tablet, and then divide that by the probability that it is a tablet. So if we go back to our tree diagram, we can see that the probability that it's a tablet and that it was made in California is that third branch, which is 0.18 or 18%. And then the probability that it was a tablet was the total here, was the 60%. And that works out to about 0.3 or 30%.